Hello guys, welcome back to the Maths Club. This is Paul Ayok, your mathematics instructor. In my last video, which I posted in my social media pages, I showed how we could expand a binomial and use the expansion to obtain the values of unknown variables. This time around, I want us to continue with binomial expansion, but how we can also use a binomial to obtain the term independent of the expansion or the coefficient of a particular term in that expansion. And for us to do that, I have decided to choose Cambridge A-Level Paper 1 of 2025, the February-March session, because that paper contains a question on binomial expansion where we are required to obtain the coefficient of a particular term. On the board is the question, and it is given as the coefficient of x to the power 7 in the expansion of px squared plus 4 all over p 4 on p x all that raised to the power 5 is 1280. Find the value of the constant p. So what is the objective of this question? The objective is to test whether or not students can effectively apply the general term of a binomial expansion in obtaining the coefficients of a particular term. So the general objective is to determine whether or not students can use the general term knowledge to obtain the coefficient of any particular term. So the question is, what is the method of handling this kind of questions? The method is simple. It is for us to isolate, take down very low the word isolate the variable x, that will make the variable x to stand alone, and then we equate it to the required power, to the required exponent. For example, the required exponent will be x to the power 7, so the required term will be x to the power 7, which means after isolating the x, we will equate it to x to the power 7. So join me guys and let's walk through the solution of this question. So recall the other day I said for any binomial expansion a plus b to the n, the general formula is given as a sum from r equal to 0 up to n of n combination r a to the n minus r b raised to the power r. From this general term formula, we can extract the general term. So what is the general term in this formula? The general term is n combination r a to the n minus r b to the r. So this is the general term. Therefore, for the expansion given to us, which is px squared plus 4 all over px raised to the power 5, we all see that our a, comparing with this, our a will be px squared. Comparing with this, our b will be equal to 4 all over px, and our n is just the exponent, which is 5. So our n is 5. So therefore, we continue by saying that this thing will be 5 combination r a, which is px squared, b a, which is px squared, all that raised to the power n minus r. Our n is 5 minus r times our b raised to the power r. Our b is 4 all over p, 4 all over px, all that raised to the power, the exponent r. So, like I said in the beginning of the video, the method of handling this kind of question is to isolate the variable x. That will make the variable x to stand alone. So I'll proceed by saying that this thing is 5 combination r. P is raised to the exponent 5 minus r. X squared is also raised to the power the exponent 5 minus r. So we can write this bracket as P raised to exponent 5 minus r times x squared raised to exponent 5 minus r times 4 all over p is raised to exponent r. So we can write it as 4 all p exponent r Then x is also raised to exponent r. So from there, I can write this as 5 combination r times p raised to the 5 minus r. The law of exponents says that when you see two exponents, because this squared is an exponent, 5 minus r is also an exponent. So when you see two exponents, multiply the two exponents. So I'll take 2 and multiply by 5 minus r. That will give me x raised to the 2 times 5, 10. 2 times negative r, negative 2r, 4 all over p to the r, x to the r. Now at this level, you realize that the x variables are already isolated. So this is a very important step for us. Now there's something you have to note. We should note that for term independent of x, we equate to x to the power 0. So if they are asking us to find the term independent of x, we will equate whatever we have here to x to the power 0. For terms in 1 all over x, 1 all over x squared, 1 all over x cubed, and so on, x squared, terms in x squared, x cubed, and so on, for this one, we equate to x to the negative 1, x to the negative 2, x to the negative 3, and so on, x to the power 2, x to the power 3, and so on. So I'm simply drawing your attention to the fact that if we are asked to find the term independent of the expansion, then we'll be equating to x to the power 0. If we are asked to find the term in 1 over x, or 1 over x squared, or 1 over x cubed, and so on, or even x squared, x cubed, and so on, we will equate to any of these respectively. Now, if you look at our question, we are asked to find the coefficient of x to the power 7. So which means we'll equate to x to the power 7, following what I have already highlighted in red. So it therefore means from this our expansion, I have x to the 10 minus 2r times x to the power r, which are already the terms that are isolated, should be equal to x to the power 7. And the law of the exponent says that when the bases are multiplying and are the same, we add the exponent. So we have x to the 10 minus 2r plus r should be equal to x to the power 7, the exponent 7. So exponents, bases are the same, so we equate the exponents. So we have 10 minus 2r plus r is equal to 7. So 10 minus r equal to 7. I'll subtract 10 on both sides. I have negative r, or 10 minus 10 minus r should be equal to 7 minus 10. So 10 minus 10 go off, negative r equal to negative 3. Therefore, my r is actually equal to 3. So the value of r is 3. I will come to this last step and substitute r as 3 anywhere I see r. I'll be substituting r as 3. So this step now becomes 5 combination 3 times p raised to the power 5 minus 3, that's p squared, times, substitute 3 for r here, will become 10 minus 6. 10 minus 6, that gives us x to the power 4, times 4 all over p raised to the power r, that's 4 on p, all that to the power 3, times x raised to the power r, so x raised to the power 3. So I will have, if I simplify everything, I'll have 5 combination 3 times p squared times, now we can already see that p p squared times x to the power 4 times x to the power 3 is actually x to the power 7 times 4 raised to the power 3 is 64 all over p cubed. So I can rewrite that as 5 combination 3. You see that p squared will cancel with p cubed down here. We are going to have p squared cancel with p cubed. We are going to have 1 on p times x times 64 times x to the power 7. If you look at what I have done, I actually cancel p squared with p squared, so it is p that will be left in the denominator. That's why I have 1 all over p times 64. My 64 is still up there, x to the power 7. Now, what is 5 combination 3? 5 combination 3 is actually 10. If you don't know how I got 5 combination 3 as 10, comment in the comment section combination and I'll reply to you how I got 5 combination 3 as 10. So just comment combination and I'll send you a message explaining how I got 5 combination 3. So 1 all over p 64 x to the power 7, which I'm going to have 64 times 10 is 640 all over p x to the power 7. So, and in this question, we were told that the coefficient of the term in x to the power 7 is 1280. What is the coefficient of the term in x to the power 7 on the board? It is 640 all over p. So it's 640 divided by p. It implies 640 divided by p, which is the coefficient, should be equal to 1280. From here, you see I'll multiply here by p, I multiply here by p. When I multiply here by p, p and p cancel out, I'll have 640 equal to, I multiply by p, 1280p. So I'll divide here by 1280, divide here by 1280. So I have 640 on 1280 should be equal to p. Therefore, my p should actually be, this is half. So my p is half because 640, 0 cancel, 0, 60. Yes, so p is half. So, ladies and gentlemen, the value of our constant p is actually half. So, as you can see, this is how we can obtain the coefficient of any term or the term independent of the expansion. Like I said, look at the notes that I gave in red. Take note, special note of the statements in red. This is how you obtain the coefficient of any expansion. You don't necessarily need to expand the binomial. You just need to extract the general term and use the same step that I have used so far. So if you like this video, comment, share, so that others can join us in the learning process. Mathematics is fun, and let's have fun together. See you in my next video.